The Mercator projection is a standard world map. This map projection is widely recognized and utilized. The Mercator projection inherently presents a distorted view of the world. The distortion is particularly noticeable in the representation of landmass sizes. Areas closer to the poles appear significantly larger than they actually are. The Mercator projection is a map widely used in educational settings, particularly in schools. Its prevalence makes it a familiar tool for teaching geography and spatial relationships. However, it is crucial to understand that the Mercator projection is not entirely accurate. Educators should emphasize its distortions to provide a comprehensive understanding of map projections. The Mercator projection is a cylindrical map projection. It distorts the size of landmasses, particularly those far from the equator. Europe appears significantly larger than it is in reality. Africa appears smaller, creating a false impression of relative size compared to Europe. Africa's landmass is significantly larger than that of Greenland. Specifically, Africa is approximately 14 times larger than Greenland in terms of total area. This notable size difference is often misrepresented in standard map projections. The Mercator projection, a common map type, introduces substantial scale distortions. These distortions particularly affect areas further from the equator, such as Greenland. Consequently, Greenland appears much larger on a Mercator map than it actually is relative to Africa. The Mercator projection was originally developed for nautical navigation. Its primary purpose was to ensure accurate representation of angles and directions. Maintaining accurate angles was prioritized over preserving accurate area sizes. This focus explains its widespread adoption despite inherent distortions in area representation. The Mercator projection historically supported imperial interests. It visually reinforced a Eurocentric worldview. This projection facilitated navigation for colonial trade routes. Empires benefited from its use in maritime activities. The map projection thus played a role in imperial expansion. The Peters projection is an alternative cartographic method. It aims to accurately represent the area of land masses on a map. This projection corrects the area distortions present in the Mercator projection. The primary goal is to provide a less Eurocentric and more equitable representation of global areas. The Peters projection is a map projection that attempts to represent areas accurately. It contrasts with other projections that distort area to preserve shapes or angles. The transformation visualizes the globe reshaping into the Peters projection. Continents are reshaped to demonstrate their true relative sizes. This projection prioritizes accurate area representation over shape conformity. The Peters projection encountered considerable resistance from political spheres. Media outlets also largely rejected the Peters projection. This opposition stemmed from its challenge to the prevailing Eurocentric worldview. The established geographical and political norms were disrupted by its equal area representation. The Peters projection faced mockery and ridicule in media outlets. This negative portrayal contributed to its suppression. The media's criticism hindered its widespread acceptance. Public perception was negatively influenced by media coverage. This ultimately limited its adoption and recognition. The media's role was significant in shaping the map's reception. Maps are constructed representations, not neutral depictions of geographical space. The creation of maps involves deliberate choices in data selection and visual encoding. Drawing borders on maps requires interpretation and decisions regarding inclusion and exclusion. Representations of geographical features are subject to cartographers' bias and perspective. Therefore, maps reflect a specific viewpoint rather than objective reality. Maps serve as fundamental tools in shaping our perception of the world. They significantly influence our understanding of geography. Maps also play a crucial role in shaping our views on political landscapes. They affect our comprehension of cultural relationships between different regions. Therefore, maps are not merely representations, but active shapers of our global perspective. The design and focus of a map can subtly guide our understanding of global dynamics. The Mercator and Peters projections are two distinct methods of representing the Earth on a flat surface. Each projection employs different techniques, leading to variations in shape and area representation. The Mercator projection preserves shape but distorts area, particularly at higher latitudes. Conversely, the Peters projection accurately represents area but distorts shape. Comparing these projections highlights the inherent trade-offs in mapmaking. The choice of projection influences perceptions and interpretations of global relationships. Map projections are essential techniques for transforming the Earth's 3D surface onto a 2D plane. This transformation is necessary for creating maps that can be easily used and interpreted. However, projecting a curved surface onto a flat one inevitably introduces distortion. Different map projections prioritize different properties such as area, shape, distance, or direction. Choosing the appropriate projection depends on the map's purpose and the specific features being represented. Understanding the types and properties of map projections is crucial for accurate map reading and analysis. Map projections are transformations that represent the Earth's curved surface on a flat plane. Different map projections prioritize the preservation of different properties. These properties include area, shape, distance, and direction. Area-preserving projections maintain the relative sizes of regions on the map. Shape-preserving projections maintain the shapes of regions on the map. No single map projection can perfectly preserve all of these properties simultaneously. Conformal projections maintain the correct shapes and angles locally on a map. The Mercator projection is a prime example of a conformal projection. While preserving shapes, conformal projections distort the areas of geographical features. These projections are beneficial for navigation but can misrepresent relative sizes of regions. Equal area projections prioritize the accurate representation of landmass sizes. These projections ensure that the area of any region on the map is proportional to its actual area on Earth. However, maintaining area accuracy inevitably leads to distortions in the shapes of landmasses. The Peters projection is a well-known example of an equal area projection. It accurately depicts the relative sizes of countries but significantly distorts their shapes. This trade-off is inherent in equal area projections, where area accuracy is favored over shape fidelity. Compromise projections aim to minimize distortion in both shape and area. These projections represent a balance between conformality and equivalence. They offer a visually appealing map of the Earth. However, they do not completely eliminate distortion. All compromise projections involve some degree of shape and area distortion. The goal is to create a more aesthetically pleasing and generally accurate representation. The Gall-Peters projection is a type of map projection. It is rectangular in shape. It is designed to be an equal area projection. This projection accurately represents the relative sizes of countries. The Gall-Peters projection is a map projection that attempts to represent areas accurately. However, it is often criticized for its distortion of shapes. This distortion can cause landmasses to appear stretched or compressed. The shape distortion is a significant drawback of this projection. Critics argue that the shape distortion affects the visual representation of countries. This can lead to misinterpretations about the relative sizes and importance of different regions. The Winkel-Trapel projection is a compromise map projection. It aims to minimize distortions in shape, area, distance, and direction. This projection is used by the National Geographic Society. It represents a balance between different map properties. Map scale is the ratio between a distance on a map and the corresponding distance on the ground. It determines the level of detail that can be represented on a map. A larger map scale shows more detail but covers a smaller area. A smaller map scale shows less detail but covers a larger area. Understanding map scale is crucial for accurate interpretation and use of maps. Different map scales are suitable for different purposes, such as navigation or regional planning. Map scale determines the level of detail and area coverage. Large-scale maps depict smaller areas with a high level of detail. These maps are useful for showing individual buildings and local features. Small-scale maps cover larger regions, but with less detail. Small-scale maps are suitable for showing continents or countries. Thematic maps are designed to visualize specific types of data. These maps focus on representing data such as population density. They can also illustrate climate patterns across different regions. Economic activities and distributions are commonly shown. Thematic maps employ various visual techniques to display data effectively. These techniques help in understanding spatial distributions and patterns. Choropleth maps are thematic maps used to visualize statistical data across geographic regions. These maps employ different colors or shading to represent data values. The data is displayed within clearly defined areas, such as countries, states, or counties. By using color intensity, choropleth maps allow for quick comparisons and pattern identification across regions. Dot density maps utilize dots as a visual representation. These dots symbolize the presence of a specific feature or phenomenon. The density of dots corresponds to the concentration or quantity of that feature. Common applications include mapping population density and agricultural production levels. Dot density maps effectively illustrate spatial distribution patterns. Cartograms intentionally distort the geographical size of areas. This distortion reflects the magnitude of a specific variable instead of actual land area. Common variables used in cartograms include population size. Another variable frequently depicted is gross domestic product, GDP. The size of an area is altered to be proportional to the variable it represents. This technique emphasizes the chosen variable's impact across different regions.